5.1, the nature of heat. Friction is something that we feel in regular everyday life. Some examples: after drilling, a drill bit would feel warm to the touch, if not hot. After sanding, sandpaper feels hot. And even if you just drag your finger across a desk, it starts to feel warm. Why? When two surfaces rub together, the parts that touch resist that movement, and they create heat. Robert Brown noticed under a microscope that pollen in a drop of water seemed to move around. Okay, hang in there with me, we'll get back to heat. When the temperature of the water was increased, this pollen started to move more. So, he was just looking again at like a microscope slide. He had one little drop of water, and on it he saw that the pollen was actually starting to move. Okay, so he went through a bunch of hypotheses and came up with this idea of Brownian motion. And all it is to say is that there is a random motion of particles. So sometimes they don't move in predicted manners. So he went through, like I said, these hypotheses of why the pollen was moving. So at first, he thought maybe the pollen is alive. He came up with that theory, tested it, and decided maybe that's not the best explanation. Later, he realized that water was made out of small particles that were in constant vibrating motion. Now, this was a GIF, and it showed water molecules moving around. I think it's really important, so I'm going to make sure it's linked to our website. And you can see the water molecules are constantly moving around. They don't fly in straight lines like gas molecules, but they do have quite a bit of motion. So what he decided, this Robert Brown, I think, was that the motion of pollen was caused by collisions between pollen and water molecules. So I have this little diagram here. The pollen is yellow and we see water molecules as blue. So this water molecule here came in and struck the pollen molecule, or grain, sorry. So did this one, and so did this one. So this pollen is going to start moving in this direction. Then more water molecules start to hit it. So it hits here, and the pollen grain is knocked this direction. And again, it'll be hit by water, and we can't predict which direction it's going to move next. All we see is the pollen moving, because of course, under a microscope, we cannot see molecules of water. So he assumed, again, that water is made out of small particles that are in constant vibrating motion, and the motion of this pollen was caused by collisions, not the pollen moving all on its own. So he did a few more experiments and he tested this theory of temperature. Again, as we warm up our water, we see that the pollen starts to move faster. Well, again, we know the pollen is not moving on its own. Therefore, the water molecules themselves must be moving faster and colliding more often with the pollen to make it move what appears to be faster. There's some practice in your textbook. Page 85, I would look at questions 2 and 3 for this topic.